Hello everyone. In this particular session, I'm going to discuss about decision tree implementation using Python. So in general, if we try to define decision tree, a decision tree is a flowchart-like structure in which we have some internal nodes and some branches. So each leaf node represents a class level and the branches represents a conjunction of features that leads to those class levels. So for implementation of decision tree in Python, first of all, I have imported the pandas library SPD, and next I tried defining some data, user-defined data for implementing the decision tree. Or we can also import some CSV files like uh, some prediction files or some data set to use our models there. But for this particular implementation, I have just defined some user defined data set. So here this is having three classes: density, it's having four attributes. This is density, grain, hardness, and class, and it has some values there. So after that, I just converted this data into some pandas data frame structure. So if we print the df variable here, what we can see is, you can see like it's converted into some tabular form with density, grain, hardness, and class, these four attributes, and these are having some values. And here if we see, we can consider the class attributes as our target variable, which is basically having oak and pine class. So for that, what I have done here is I did some level encoding for the categorical variables, because to train our model we need some numerical variables, not categorical. So for that, what we have to do is we need to convert those those categorical variables into some numerical variables. For that purpose, I have used the level encoding for this dependent as well as the independent variables. So here you can see I have imported this level encoding library from sklearn preprocessing. So here I have defined three objects for this level encoding class, and here I have defined three new columns for my dataset: density and grain and hardness, and which is basically containing the values, the numerical values that's after conversion of those categorical variables. So here if we execute this command, you can see this df head, it will print the first and first five rows. So here you can see it added some new columns: density and grain and hardness, and which is basically conversion of these three attributes into some numerical format. So what we can do here is we can just remove all these old columns because it's no use now. So I have dropped all those density, grain, and hardness here. This is the command for dropping all those three old attributes. So after that, I tried creating the new data frame by using these three new columns with class attributes. So here if we print this df underscore n, this is the new data frame. It will basically giving the density, grain, hardness, and class. This is our final and the new data frame that you can use for training the model. So next comes the feature separation. So feature separation is basically, it's a separation of the dependent and the independent variables. So for that, what we can do is we can consider density and gradient and hardness as our independent variables and class as our dependent variables. So for that, I have separated all those. So here inputs is considered as all the attributes excluding the class attribute, and for target I have directly assigned the class attribute. Next, I tried defining the model. So for that, I have imported the sklearn, the tree model. So here I have defined my decision tree classifier, this one, tree dot decision tree classifier, and I have fit the model with my inputs, this input and the target. So after executing this command, what I can do is I can construct a tree structure. So for constructing the tree structure, I have just imported the matplotlib library. So matplotlib library, it can be used for this visualization and all, as we all know. So here I have features are separated as fn and class are separated as cn. So I have separated all those. Then I have tried this tree.plot tree model, like tree.plot tree function to create the tree structure. So for that I pass the model feature names as fn as we have already define it, and the class name says cn, same thing, and the field is true. So after execution of this command, we can see our tree structure. So it will basically show all these parameters that can be used or that can be calculated during the formation of this decision tree. So here we have Gini index and samples and values, all these are visualized in a very proper order. So next, finally, I tried finding the accuracy of this model. So here I have passed the like model.score. I passed the inputs and the target variable, and the accuracy is coming near is 0.75, which is basically 75%. It's a good accuracy after all. So finally, I tried some test cases for that. So for that, I have use the model.predict class and I pass 0 1 0. This is a random class that I have chosen, and when I execute this, it's giving the output as O, predicted output as O. Similarly, I have also tried one more case like 0 1 1, so it's giving pine. So that's all about this decision tree construction using Python. And also, one more thing I want to mention is I have mentioned some data science and machine learning books in the description, so you can go to this if someone wants to buy something or buy some books related to data science.